Hey guys, today I'm going to walk you through an example of a limit problem using the difference quotient. So what is the difference quotient? Well, difference minus quotient divide. Okay, so that's what it is. It's just throwing a limit there. So let me show you what that looks like. So here is an expanded, a non-simplified form of the difference quotient where we have the limit of x plus h, f of x plus h minus f of x all over x plus h minus x as h goes to 0. So here we see the difference being we're subtracting two values on top and on bottom. Remember, hopefully you're seeing f of x is the same thing as y, right? So we're subtracting two y values up top. And then these are the x values inside of here. So this is like x2 minus x1, y2 minus y1 over x2 minus x1. So hopefully you realize that that's what we're talking about, slope here, but we'll get to that later on in calculus. For now, you just need to know that this is the difference quotient, and what I can do with this is I can simplify this. So this is why you might have seen something else in different textbooks, different examples. If I simplify this, I got x and minus x, they cancel each other out, and they just leave me with h on the bottom. So this is what I have after simplifying, and this is what we're going to work with. The limit of f of x plus h minus f of x all over h as h goes to 0. All right, so we're going to get to this example in just a minute, but I wanted to make sure I reference the colors here. The difference being subtracting, that's why I got it in yellow there, and then the quotient being dividing, that's why I have it in orange there. So just to kind of keep these connections in mind as we continue. So what we want to do is we want to find the difference quotient for the function f of x equals 3x minus 2. Again, we're going to revert to this as something different later when we look at y2 minus y1 over x2 minus x1. But for now, we just need to know how do we evaluate a limit with the difference quotient and this function. So my function, what I need to do is I need to find f of x plus h using my function, and then I already have f of x, and then I'll just evaluate it from there. So let's go ahead and find f of x plus h first. Remember, f of x plus h is not given, but f of x is. So all I have to do is plug in x plus h. I will use a different color here. I'm going to plug in x plus h into my function, just like we did with compositions, right? So when we plug x plus h in here, I'm going to write my function f of x without the x. I'm going to write a parentheses here. So it should be 3 parentheses, 3 times parentheses, and then minus 2. Inside of my parentheses, I'm plugging in this x plus h. So x plus h should go there. Okay? So now I'm going to go ahead and do this the long way the first time, and then we can simplify this later. So I'm just going to plug in x plus h into my function. I already know f of x, and then I'm going to go ahead and start evaluating, simplifying before I evaluate. So the limit of f of x plus h, which is 3 times x plus h minus 2, I'm going to put that in a big old bracket because that is my f of x plus h, right? This whole bracket is my f of x plus h minus f of x. Well, f of x is 3x minus 2, so I'm going to put that in the bracket as well, 3x minus 2. Okay, so I have f of x plus h in the first bracket and f of x in the second bracket, and I'm subtracting those. And then all over h. And I'm evaluating this as h goes to 0. Okay, now remember, if we're evaluating this limit, well, we don't even have to worry about simplifying this, right? We can always, your instinct is to try direct substitution. So what happens if I plug in h on the top? Well, let's not even worry about that because let's go straight to the bottom. The only thing we have on the bottom is h. So if I plug in 0 on the bottom, then I know I have either one of two things if I only have 0 on the bottom. Either it's an asymptote or I have to do some more work, right? It could be factoring, could be conjugate and cancel. So let's see what happens if I plug in 0 now on the top. So 3 times x plus 0, well, x plus 0 is just x, right? So 3x minus 2 is what I have, minus 3x minus 2. Well, I'm subtracting the same thing, so that's going to give me 0 on top as well, right? So I'm always, when I do the difference quotient, just know that you're always going to get 0 over 0. Always when you're doing the difference quotient. Okay, so what this means is now I got to do some simplifying here and then see what I got to do. Do I got to factor and cancel? Do I have to conjugate and cancel? What? So let's go ahead and simplify what we have before continuing, before overthinking things. So let's go ahead and distribute this 3 here and here. So I'm going to write the limit as h. And I'm saying this wrong. You know, h goes to 0 said last. But the limit of 3 times x, which is 3x, 3 times h, which is 3h, and then minus 2. Now I can take away this parentheses or this bracket because there's nothing outside of it that I need to distribute. And then for the second one, I'm going to distribute this negative here and here. So that should be a minus 3x and a plus 2. So hopefully you see why I put brackets around both of these terms now, so that the second one is the important one because I'm distributing that negative to each of those terms. Change the minus 2 to a plus 2 here, all divided by h. And let me just go ahead and put a dividing line, a dashed line here, separating the two, so you don't think that this h is part of this next step. All right, cool. So what should happen here is we are canceling a whole bunch of things. It should always happen that you're canceling everything involving an x here. Okay, not everything, but most things involving the x. Okay, so you should basically cancel out your original function. So my original function is 3x minus 2. I should cancel that out. Let's see what happens. I have a plus 3x here and a minus 3x here. Those two cancel. I have a 3h. I can't combine it with any h terms over here. And then I have a minus 2 and a plus 2. Those also cancel. So this, and I should be putting my equal signs here, but it's kind of implied, is the limit of, what do I have left? Well, I have a 3h left over on top, and then just an h left over on bottom. So the limit of 3h over h as h goes to 0. Well, can I plug in 0 here for h? I can try, but I'm going to get 0 over 0. So what else could I do with this? Well, if you're looking at this, hopefully you see you can just simplify. So this becomes the limit of 3 as h goes to 0. Now this last step is redundant, but I'm just writing it because in other cases you will still be able to plug in 0 for h. But as you can see, I have the limit of 3 as h goes to 0. There's nowhere to plug in h, so my limit stays as 3. So this is the answer to this question. The difference quotient for the function f of x equals 3x minus 2 is equal to 3. Okay, so just a quick rundown, a quick review of what we did. We started off with the simplified difference quotient. We found f of x plus h first. We plugged it into the difference quotient with brackets, and we plugged in f of x with brackets. That's where I got this step right here. I distributed, I simplified the top, and remember on the top, your x's should always cancel here. Your original function should always cancel. So 3x minus 2 canceled, 3x and negative 3x, positive 2, I'm sorry, minus 2 and plus 2 canceled. And then that left me with nothing but h's. So 3h over h is what I'm left with. I can cancel out that h, I'm left with 3. Remember, this step is redundant because there's no more h's to plug in this case. So I can just say, oh, I'm left with 3, 3 is my answer. Okay, so my answer was 3. I hope this video helps you with your homework that is due tonight.